In lesson 7.5, we're talking about division properties of exponents, and you've actually already seen me do a lot of this just throughout the chapter, but now we're going to put a rule to it so that you have one more thing you can use, but you can always go back to what we've talked about before. So this is example 1, write it down, and then go ahead and copy what's on the left. I'm going to move this up, hit pause, and hit play when you're ready. So you're talking about dividing powers that have the same base. You're always looking for the same base when you're going to do this. And sometimes you'll have several bases, but you're just looking for bases that are the same. And when you have that, you're going to subtract top exponent subtracting bottom exponent. It has to be in that order. It has to be m minus n. You cannot flip it around. It's not bottom minus top. And you'll see why as we go through the examples. So just remember, top minus the bottom. And actually the first example will show you a good reason that works. So hit pause, hit play when you're ready to start. I'm going to walk you through this kind of the long way first, just so you see how it works in the end. We have 1, 2, 3, 4, 5, 6 A's. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 A's. For every matching set here, 1 cancels. So 1, 2, 3, 4, 5, 6 end up canceling. Notice you end up with a 1 at the top. Okay, a lot of kids forget about that. When you have nothing left at the top, there's still a 1 there. So this would equal 1 over, and now I count up my A's. 1, 2, 3, 4, 5, 6, 7, 8. A to the 8th. Okay, the other way of doing that would have been to say A, top exponent minus bottom exponent, 6 minus 14. Which ends up equaling a to the negative 8, and remember you're not allowed to leave something with a negative exponent, so you would move that to the bottom of a fraction. Same answer, 2 ways to get it. That is why you're not allowed to swap these around. If you had swapped these around and you had said 14 minus 6, you would have ended up with a positive answer here, and you would have ended up without the correct final expression. So it's always top exponent minus bottom exponent. Let's try another one. C to the negative 1 d cubed over c to the 5th d to the negative 4th. Again, a few different ways you could do this. So you could follow the rule. I'm going to put rule here. Okay, this is using the rule we're learning. C, I see a like base of C. So I'm going to highlight that base of C in yellow. That is a like. So I bring the base over, and then remember, top exponent minus bottom. So negative 1 minus 5. And then I see D, maybe I'm going to highlight that in green. Hopefully my green isn't too dark. No. And I end up with D, top exponent minus bottom. So 3 minus negative 4. Remember, double negatives there. Then I would continue to simplify it. I end up with C to the negative 6, D to the 7th, because 3 plus 4 is 7. And this wouldn't be finished because I still have a negative to deal with. So final would be D to the 7th over C to the 6th. Okay, that's one way to do it. Or you could use the negative exponents rule, where you move them and then you start simplifying from there. So if I'd done that, it would have looked something like this. I would have had c to the fifth would have stayed, times c to the first would have moved down, d to the third would have stayed, d to the fourth would have moved up. So everyone see how that worked? So this d to the fourth, negative 4 moved up and became positive. C to the negative 1 moved down and became positive. Now I have like bases that I can combine. So I have a total of 7 d's and a total of 6 c's. Same simplified expression. And the problem is there really isn't a right or a wrong way, and there isn't one that's always easier. It depends on every single problem is a little bit different. Sometimes you'll see this rule is easier to use, sometimes you'll see this rule is easier to use. Use whatever works for you that's best. I want you to go ahead and write these 5 down, try each of them on your own, and then hit play when you're ready. So again, if we're using the rule here, we bring up our like base of b, 4 subtracting 9, top subtracting the bottom exponent, and we end up with b to the negative 5. We can't have a negative, so 1 over b to the fifth. And that's the final simplified answer. Or you could have written 4 out on the top, 9 out of the bottom, crossed them out, you would have had the same thing, just takes longer. Okay, same rule, like base of z, 10 subtracting 5. Notice your larger number is on the top. You should have your leftovers at the top. When your larger number is at the bottom, you should have your leftovers in your denominator at the bottom, which equals z to the fifth, and it's done, because it's not a negative, so I don't have to go any further. On this one, you're looking for your like bases, so you had a's, and then you had your b's. So you bring that base of a up, and you have 2 subtracting 4. Bring the base of b up, and you have, that's a 1, 1 subtracting 3. Whenever you don't see something there, it's a 1. And then it should have been a to the negative 2, b to the negative 2. And you can't have that, so you would go one step further, 1 over a squared b squared, to make them positive exponents. Number 4, again, you're looking for those like bases. There's m's. So m to the negative 1 minus 3, or someone might have noticed, oh, I can just move m to the 1 down and combine them. I have m to the 4th at the bottom, which you're going to end up getting anyway. N to the 2 minus 1, you need that 1 there, which ends up being m to the negative 4, n to the first. That needs to move down. So n over m to the 4th. Okay, again, just looking for like bases. X 2 minus 1, y negative 1 minus 1. Be really careful with signs there because that's important. That changes things. Some of you might have canceled that, but it's not. That negative 1 is moving that down. You should end up with a y squared at the bottom in the end. And then z 4 minus negative 3. Those double negatives become plus. Notice that's going to move up. 4 plus 3 is 7, and that should end up being 4 plus 3 up at the top. So this ends up being x to the first, y to the negative 2, z to the 7th, and then you would write it without 0 exponents, without 1 exponents, and move negatives. So we have an x, we have a z to the 7th, and we have a y that needed to move down to become a positive exponent. We're going to skip example 2 because if you noticed earlier in the chapter, we skipped lesson 7.2, which was scientific notation. We're going to go back to scientific notation at the end of the year, and then we'll apply it to some word problems. So any word problem that you come across in chapter 7 that has scientific notation, don't worry about those yet. We haven't learned them. But we're on to example 3, which is raising a quotient to a power. Quotient, right here, is division. Fraction bar is division. The really nice thing about this rule is it's exactly the same as it was with your products with multiplying. All you're going to do is make sure every part of that quotient gets distributed, that exponent distributed to it. So it's the exact same rule. You're just going to take anything in the denominator, anything in the numerator. You're going to make sure everything, top and bottom of the fraction, has cubed distributed to it. So we have 4 cubed over x squared cubed. And then you'd have 4 times 4 times 4, which would be 64, over x squared times x squared times x squared, or using the rule, 2 times 3, x to the 6th. Let's try a few more of those. Three over x squared squared. So again, 3 squared. It's the only part of the term at the top in my numerator, so I don't have to distribute it to a bunch of pieces. Now I look at my denominator, x squared squared. 3 squared is 9. X squared squared is 4th. So 9 over x to the 4th. Another example, same type of thing, just practicing it a few times. So I have x to the first power cubed over y squared cubed. I end up with x cubed over 2, 2, 2. So y to the 6th. And I'm done. Write this on the left and hit play when you're ready to move on to example 4. Here's example 4. Go ahead and, after I'm done explaining it, hit pause and then just play when you're ready to continue. Notice here we have a negative on the outside of the parentheses with the exponent. You can distribute this in, and you would end up with 3 to the negative 2. I'm just going to show you, and then you can hit pause after. 3 to the negative 2 over 5 to the negative 2. But now you know that this is going to have to move up to become a positive exponent, and that's going to have to move down to become a positive exponent. So you're going to end up swapping these anyway. You're going to end up with a 5 squared at the top and a 3 squared at the bottom. Okay, you can do it that way, that's fine. Or instead of distributing that negative exponent, right away when you see a negative out here, you could just take the reciprocal of what's inside the parentheses, flip it around before you even distribute, and this can become positive right away. So that's what that shows. Hit pause, finish writing all this down, and then hit play to finish this example with me. So from here, if we had done it this way, then we would have 25 over 9. Now, if you don't like dealing with these negative exponents, then this is what I would have done. I would have recognized negative exponent. I want it to become positive. So 5 over 3, okay, that's the reciprocal. And then squared, positive. You have to do both steps to make this work. So reciprocal, and then that becomes positive. Basically what you did is distributed your negative without the squared, and then these flipped around. And what you have to make sure of is as these get bigger, when your numerator and your denominator have more products in them, you have to take everything from the top, everything from the bottom, and swap them. Otherwise it gets too confusing. Now I would distribute my squared, and I would have 5 squared over 3 squared, which ends up being 25 over 9. Let's try a few of those. Here's the next example. There is a negative there. It's kind of blending. So in parentheses, I have a negative 2x divided by y. I have this negative exponent here. Because this negative is just kind of off to the side, it can just stay off to the side. If it had been at the top or the bottom originally, just keep it with whatever it was with at that point. It's easier than trying to figure out where to put it. But since it's off to the side, I'm just going to say, okay, I'm leaving my negative where it's at. I'm taking anything in my denominator and moving it up to my numerator, anything in my numerator and moving it down. Even if one of these had had a negative exponent, I still would have moved it with the negative exponent, because all I'm thinking about right now is that. I'm just trying to get rid of that negative right there. And now it's to the 4th power. Okay, now from here I can follow my next steps. So if you want, you can deal with your negative. You have a negative times a negative times a negative times a negative. 4 times, which should become positive. If you need to, make yourself a note here. Negative 4 times becomes positive. Now I have y to the 4th over 2 to the 4th x to the 4th, which ends up being y to the 4th over 2 times 2 times 2 times 2, not 2 times 4, which ends up being 16 x to the 4th. Alright, so again, I come across this problem and immediately this is what jumps out at me. I want to get rid of that negative exponent right off the bat. So, keep my parentheses. Anything in my denominator moves up. Anything in my numerator moves down. And now I just have to the 5th power. I end up with 2 to the 5th power over negative 1 to the 5th power. 2 times 2 times 2 times 2 times 2 ends up being 32 over negative 1 times negative 1 times negative 1, odd exponent, negative is in the parentheses, so it ends up being over negative 1. So my final answer here should be negative 32. This is an S, not a 5. So this should jump out at you right away. Take the reciprocal, keep your parentheses, S goes to the top, 2R goes to the numerator, or the denominator, sorry. This becomes a positive 1. Now, really nice, anything to the 1 power is what it is, so you're done. S over 2R. Alright, let's look at one more. 7a to the negative 3 over m to the negative 2. Remember earlier I said even if you have a negative here, don't even look at that yet. You're just flipping everything in the numerator to the denominator, denominator to numerator when you see this negative out here. So it should look like this. M went up to the numerator, 7a to the negative 3 went up to the denominator, and that becomes a 2. Now you're going to distribute this 2 to each piece. I'm going to go ahead and start over here just so I have room, which ends up being m squared over 7 squared a to the negative 3 squared. You end up with m squared over 7 times 7, not 7 times 2, which is 49, a to the negative 6. Now you know this negative 6 needs to move. So a to the 6th, m to the 2nd over 49 would be your final simplified expression. Notice I put A first because it's first in the alphabet there. You're going to get a lot of opportunities to practice all different variations of these and some that have even more stuff. So just ask me questions as you have them in class.